So how in the world do you do synthetic division with imaginary numbers? Well, you've clicked on the right video, my friend. That's what I'm here to teach you. Let's take a look at this example. We have x plus 1 being divided now by x plus I, where I is an imaginary number. It's just something that can be defined as the square root of, let's say, -1. You cannot take the square root of a negative number, because when you take the square root of something, you're basically asking yourself, what number multiplied by itself will give me the value inside of the square root, meaning -1? And no two numbers multiplied by itself will give you a negative number. It's just not possible. And therefore, it's imaginary, it's made up. Now, don't confuse an imaginary number with complex numbers. An imaginary number is simply what I just defined, and a complex number is going to be now this imaginary unit plus some real or another imaginary number. So basically, this could be a variable, it could be a number, it could be 2, it doesn't matter. That would be considered a complex number now, all right? Okay. Now, to the synthetic division part. So in order to set up your table, what you're going to do is you're going to look at your numerator, all right, known as your dividend. You're going to locate the highest power of x. In this case, it's just 1. And you're going to add, then to that power, you're going to add 1 to it. So for a total of 2, that's going to tell you how many columns you're going to have inside of your synthetic division table. Take a look. Bam. So as you can see, we have 2 columns here inside of this synthetic division table. And what's going to go in here is the coefficient of your x term. And then what's going to go in this little cell here is going to be your constant term. So look back to the dividend, or aka the numerator. Locate the coefficient of your x term. It's just a 1, so plug in 1 there. And then locate your constant term, and it's just a 1. So that takes care of that. Easy peasy. Now focus on your denominator, or aka the divisor. You're going to take it, whatever it is, set it equal to 0, and you're going to solve that for now x. And the reason why you're going to do that is because that's going to help you find the value you're going to plug in outside now of your synthetic division table. I don't care if it's I, negative I, x, a, b, c, d, e, f, g, some Greek alpha. It doesn't really make a difference, all right? That's what you're going to plug in here. Now, once you have the top row filled out, you just got to follow a simple series of steps. Take the first coefficient value, drop it all the way down. This box is red, and what that means is that nothing's going to go in it. Now, take the value at the bottom, multiply it by the outside value of negative I, and that's going to be a value of just negative I, right? 1 times negative I is negative I. Then what you're going to do is just add this column together. So that's just simply going to be 1 minus now I. You can't actually subtract them, right? So you're just going to write the expression there. And this pattern would continue. If you had more, columns here, you take this value, multiply it by that outside value, put it in the next cell, add that column together, etc. All right. Take a look if you want to detect the patterns a little more. Take a look at an example. I got like 50 of them out there for synthetic division, where your highest power of x is going to be something like cubed or to the 4th. Okay. So now keep in mind what these values represent. This will represent your remainder. This will represent your constant. If you had more columns, then that would be the x. That would be the x squared, etc., etc. You're always going to start with the remainder and work your way to the left. You got to kind of detect that pattern again. Check out one of the other videos. One thing is, before then you write out your quotient, always double check your divisor, locate the x, and identify its coefficient. In this problem, it's a 1, so it really won't do anything. But if that were to change, what would happen is you would take this coefficient, okay, and you would divide then every term except the remainder. Don't do it to this. Every other term, though, you would divide by that coefficient. Obviously, dividing something by 1 doesn't do anything. But if this were a 4, then this would now be 1/4. That would be your new constant term, okay? In any case, I just wanted to fill you in on that in case the problem changes. Now all you have to do is just write out your quotient here. So it's going to be, the constant term is a 1, so write 1. Your remainder then is going to be plus now, whatever it is, 1 plus I, and you're always going to put that remainder value over then your divisor, x plus I. And guess what? Finito. Thank you so very much for tuning in. I really do appreciate it. If this video helped you out at all, if you don't mind, just recommend our channel to maybe some of your classmates. We'd love to help you out and your friends with more problems. By the way, we don't only have math here, we have physics and chemistry as well, and I think you'll like a lot of the resources we're building, so definitely check our channel out. Take care.